Hi guys, and welcome to this video on gradient and intercept form. We are finally getting to the funky stuff. If you watched all the other videos, I'm so sorry. It's taken a long time to get here, but we are here. My name's Darren, Maths Guru. Thank you very much for joining me. My channel is filled with humour and entertaining maths just to make it easier for you to understand. If you can, subscribe to my YouTube channel. Just lets me know you're watching. Right? It's probably just you and me and my mother, to be perfectly honest with you. Leave a message below at any point in the video if you go, actually, that was useful. Tell your mates and tell your teachers. It means so much to me to try and help as many people as I possibly can. What are we looking at today? Learning objectives. Woof. Know what the gradient-intercept form of a straight line is. It's been building to this. We've already talked about it 97 times, but let's formalize it. Be able to find the gradient and intercept from an equation. You can do this. Smash it. Be able to write equations by reading the gradient and intercept from a straight line, and be able to rearrange linear equations. I think I have recapped this particular thing over and over again, but when we are drawing straight lines, there are various pieces of information that are really, really important to us. Number one, the first thing is, what is the label on my y-axis? What is here? Normally we write the letter y. What is the label on my x-axis? Normally we write the letter x. Where is the line cutting the y-axis? What is the coordinate value there? And in which case, if I have a look, 0, 2. Hopefully you can read off coordinates, guys. If not, there is probably a video on mathsguru.com that will help you do that. What else do I need to know? I need to be able to choose 2 points on my line to work out my gradient. So my gradient in this situation is 1 divided by 1, which is 1. Now, once I've got all of that information, believe it or not, the rest of this is child's play because we just link them together with what we call the gradient-intercept equation of a straight line, or more normally, the equation of a straight line. Now, before I get into the fun stuff, let's just check what we know. If we look here at each of these graphs, one's in red, one's in blue, and one is in green. What can we see? Well, they are in fact parallel. They are all sloping. Those lines will never, ever meet. P-A-R-A-L-L-E-L. I don't know why I spelled that. I just like to prove the fact I can spell. I'm a maths teacher. I can do numbers, but occasionally I can do letters. So they are parallel. What I want you to then do is look at these three equations. These three equations down here are the ones that created those lines. Now notice they all start y equals. They all have different numbers at the ends, 1, 3 and -2. But what do you notice about the number in front of the x? They all have 2x in them. That's interesting. I wonder what would happen if I worked out the gradient of this line here. So there, I'm going to go to there. I'm going to go across and up. Now remember, don't count squares. Working out the gradient by counting squares is a horrible idea, all right, because you're going to make silly mistakes. So we know that that is 1 unit across because it's going between 2 and 3. It is 2 units up because it's going between 2 and 4. My gradient there then would be 2 on what? Hold on a moment. Hold the farm. Yeah, that value there is the gradient. And that's why all of those lines there are parallel. They all have parallel lines, the same gradient. They all have a 2 in them. But what about this +1, +3, -2? If you'd watched my previous video, look at that point there. That happens to be a 3. What about that point there? Happens to be a 1. What about that point there? Happens to be -2. Hold on a minute, I've got a -2. I've got a +3 and a +1, and again, those are my intercepts. If you can work this out, you are now a gun. Every single line, all you need to know about it is, what is the letter used on there? What is the letter used on there? What is the value it crosses? And what is its gradient? So, to formalize this into something more posh for mathematics, we have the equation of a straight line can be given as y equals mx. All right, y equals mx plus c. I don't know why we chose the m to stand for gradient, but we'll just go with it. And I've even less of an idea why we have a c for intercept, but. And the important thing here is that that c must be the y-intercept. If you look at this, it also crosses an axis down here. But that's not the y. And sadly, a lot of people make silly mistakes by reading off this value here. Please don't. It is not that value there. It is that +2 where it crosses the y-axis intercept. And so if I read any graph whatsoever, so long as I know where it crosses the y-axis and I know the gradient, I can write down this equation, easy peasy lemon squeezy. Now, again, what you need to notice is all equations to be written in this format must start y equals. They cannot start 2y equals. They can't start a half y equals. They can't be y plus x equals 2. Well, I'll come back to that later. But for gradient intercept form, it can't be that form either. It has to start y equals. Now, all of these equations here start y equals, but what do you notice? They've all got different gradients, and I've done that deliberately. So can you now stop the video in a moment and look at each of these equations and work out which is which on my graph? And you're going to say, of course I can. They're colored. And I'm like, okay, then don't stop the video. Whew, so aggressive. All right, but here, let's look at the red line. We've got 2x plus 1. There's my +1, it crosses through there. My gradient is +2. Positive gradients slope up. This line here, sloping up. The green line, sloping up. The purple line, sloping up. They've all got positive numbers in front of the x. The blue line, I think that's blue, has a negative number. This one is sloping down. And we'll notice that here, my x value, or the value in front of the x, is negative. So gradients can be positive and negative. They can also be 0 and undefined. More on that later. So let's write down the gradient and intercept from an equation. Thank you very much to Cambridge for allowing me to use your examples in this video. You guys rock. You are quite amazing. Thank you so much. So we're given 4 equations here. Can we write down the gradient and the intercept? So remember, gradient or equation is y equals mx plus c. The value in front of the x is the gradient, and the value there is the intercept. Now, so for the first equation, I've got y equals 2x plus 1. Therefore, my gradient is 2, and my intercept is. Now, I slightly disagree with the book here, because in many cases, they will just write down the value of 1. But as far as I'm concerned, the intercept is a coordinate. So I think it shouldn't be written as 1. I think it should be written as a coordinate, which is 0, 1. Now, there may be hundreds of teachers out there, thousands even, who are going to disagree with me. I'm sorry. I just know for VCE, we have to get them to write the coordinates down for lines that cross axes and stuff. It makes much more sense to start it now. Why teach it weirdly now? Let's look at the next one. Y equals minus 3x. Well, that's easy. My m is equal to minus 3. But what's my value of c? Well, there isn't anything there. Exactly, there's nothing there. It's 0, 0. I know, I really should get up more. I've got y equals 5x minus 2. So, whoops, my value of m is equal to 5, and my value of c is equal to 0, minus 2. And remember, if you think about it, this is going to cross down here somewhere at minus 2. And so the coordinate is none across, 2 down. And finally, y equals 6x, my m is equal to 6, and my c is once again equal to 0, 0. What is so important is, again, all of these equations start with y equals. If they don't, you're going to have to use your algebra to rearrange them. Oh, look at this! I may have known this was coming. So for example, they're saying here, if I've got 4x plus 2y equals 10, that's actually not in a gradient intercept form. Why? No pun intended. Because the y is not on its own. So I'm now going to have to use my algebra to get the y on its own, to rearrange. I want the y on its own. The 2 and the y are stuck together with a kissy, so I'm going to get rid of the 4x first. How do I do that? I'm going to subtract 4x from both sides. So I'm going to get 2y is equal to left. I've got 10 minus 4x. And there's a trick here, guys, but we'll come back to that in a moment. I want the y on its own. I've got to split apart the kissing couples and make it so that we divide everything by 2. If you have no idea what I'm talking about with kissing couples, there are other videos with regards to maths where I teach about kisses and bunk beds and fractions and prison guards and all sorts of stuff as well, just to help you understand algebra. Divide everything by 2, and it has to be everything. 10 divided by 2 is 5. Minus 4 divided by 2 is minus 2, and there we go, ka-ching. Now, a word of warning, while this is okay, our gradient intercept form is written as y equals mx plus c. Our x term is first. So I'm going to swap them around, and remembering that that minus sign belongs to the 2, I'm going to write that as minus 2x plus 5. There we go. Now, rearranging that, I can now write down that my gradient is negative 2, and my intercept is 0, 5. Maths starts to mesh together again in year 9, and that's where it's really important that you understand this, all right? So let's just do it again. Bearing in mind, this here has got its own name. It's called the intercept form. We've met it in a previous example. Sometimes drawing equations is so much easier when it's in that form, and you're going to meet it again later on in simultaneous equations. But let's just do it again. We've got x plus 2y equals 6. Is the y on its own? No. So leave the kissing couple together, separate everything else. I'm going to get rid of this x, which is actually a plus x, and I'm going to subtract x from both sides. Bye-bye, sayonara. I get 2y is 6 minus x. Yeah, don't like that format, but leave it for the moment. I can now split up the kissing couple, so I'm going to divide everything by 2, and again, everything is divided by 2. 6 divided by 2 is 3. Now, x divided by 2 is a half of x. That becomes minus a half of x. And notice I write it like that, not x on 2. Sadly, that confuses people. I don't like it in that format, so I'm going to move my x term, which is minus a half x first, and then the plus 3. And ka-ching, I have my gradient is minus a half, and my intercept is 0, 3. So, coming soon. Can we work out the equation of a straight line without actually drawing a graph? Because we're not going to be able to be in a situation where we're always going to be drawing graphs, are we? No, it's going to get too tedious after a while. Now, I've got these 2 points here, which I have for the moment drawn on a graph for you. You could join them together. This is going to be really inaccurate, and hopefully find out my equation. Because remember, for my equation, y equals mx plus c, I need the gradient, and I need the intercept. I can probably read that intercept off. I can probably find the gradient. But is there a way of doing it without drawing the graph? Well, actually, that's coming in one of my later videos. I'll leave this screen here for you to see whether you want to work it out for yourself while I do my final remarks. But thank you very much. Hopefully that has made sense. Y equals mx plus c. Rules the day. My name's Darren, Maths Guru. If you can subscribe, please do so. Like the video, leave a comment, tell your mates. Tell your teachers. If not, hopefully I'll see you in another video. You take care, guys. See you again soon.